At Chukchi Sea, some icebergs may have left during melt season while the ice surrounding them all melt. How does it happen? It is because of the Taylor columns. According to the Taylor-Proudman theorem, fluid will move in two dimensions under the fast rotation of the Earth. When an incompressible fluid is under geostrophic balance, change of velocity of the fluid with the change of height will be zero, which means the velocity of fluid in vertical direction will be constant. When there is an immovable obstacle, it holds the vertical velocity of the fluid to be zero. Fast rotating fluid cannot go through it. They can just pass around it at all heights like passing around a column. This stationary column of fluid above the obstacle is called a Taylor column. We can know more about the Taylor columns in this experiment. Our setup demonstrates the mechanism in the northern hemisphere. First, place the circular insert in the water tank. Place an obstacle inside the circular insert. Fill the tank with water until its depth is about 1/2 of the tank. Set the tank into rotation. Say a speed of 20 revolutions per minute. Wait until the water is in solid body rotation. This may take a few minutes. Paper dots flows and track the surface flow. We can see that the paper dots can only spin around and pass the water surface just above the obstacle, but cannot go straightly through it. Add some colored dye to indicate the flow of water. Clearly that a stationary water column is formed above the obstacle. The dye can only pass around it but cannot go through it. In the atmosphere, as air is a gas that can vary its density easily, Taylor column can hardly form. However, in the ocean, water has almost the same density throughout. Taylor column can form where seamounts present. Let us go back to the question in the beginning. At Chukchi Sea, there are seamounts, which act as obstacles and form Taylor columns. While the cold water is trapped inside the Taylor columns, this can keep the iceberg remain for 2 weeks after all the surrounding ice melted.